Hey, and welcome. If you're looking to really level up your SQL skills, to go beyond just the basic select statements, then you have come to exactly the right place. Today, we're diving into two incredibly powerful concepts that are just essential for any kind of advanced data work: subqueries and common table expressions, also known as CTEs. And trust me, by the end of this, you'll get what they are and, more importantly, when to use which.
So, here's the game plan. We're going to start with the super simple idea behind subqueries. Then we'll check out the different types you'll run into. After that, we'll look at a much cleaner, more modern approach with CTEs. We'll even unlock their real superpower, recursion, before we wrap it all up with a practical guide on picking the right tool and, of course, how to avoid the common mistakes everyone makes. All right, first step, let's demystify the subquery. Before we get all tangled up in the syntax and the different kinds, it's so important to get the core idea down. And honestly, it's way more intuitive than it sounds.
Just think about it in plain English for a second. If I asked you, hey, find all the students who scored above the class average, what's the very first thing you have to do? You can't answer the main question until you know the class average, right? You have to answer that first. Well, that little question you answer first, that's the whole idea behind a subquery. It runs, gets an answer, and feeds it into your main question.
Okay, so for this whole explainer, we're going to use this two-part approach to make sure these ideas really stick. We'll start with what I call the kid explanation, just a simple gut-level way to think about it. And then we'll follow that up with the pro explanation, the more precise technical definition you'd use in an interview or with your team. This way, you get the why and the what.
So here's our pro explanation. A subquery is simply a query that's nested inside another SQL statement. It runs first, it gets a result, and that result could be a single number, a list of things, or even a whole temporary table. And then it passes that result to the outer main query, which uses it to finish its job.
Okay, now that we've got the basic concept down, let's open up the toolkit. See, subqueries come in a couple of different flavors, and knowing the difference is absolutely crucial, especially when you start caring about how fast your queries run. The most common one you'll see is the scalar subquery. The main rule here, and you got to remember this, is that it must return exactly one value. That means one single row with one single column. Our class average example, that's a perfect scalar subquery. The inner query runs, finds one number, the average, and the outer query uses it. Simple as that. So, to bring it back to our simple analogy, the kid explanation for a scalar subquery is just this. It's one number. If your inner question needs to spit out a single value for your main question, you're dealing with a scalar subquery. But what if your inner question needs to give you like a whole new data set for your outer query to work with? That's where a table subquery comes into play. This type can return a full result set, multiple rows, multiple columns, that your main query can then use almost like it's a real temporary table. We often call this a derived table because, well, its data is derived from your subquery. And you guessed it, here's the simple way to think about it. The kid explanation is just that you're making a temporary table, just for this question. It's a custom-built little table that only exists for a split second while your main query runs. It's awesome for breaking a really complex problem into smaller, more manageable steps. Now pay close attention here, because this is probably the most critical concept when it comes to performance. We have uncorrelated versus correlated subqueries. An uncorrelated one is simple. It runs one time, finds its answer, like the overall class average, and it's done. A correlated subquery, though, is connected to the outer query. It has to run over and over and over again, once for every single row the outer query is looking at. Imagine calculating the average score for each student's individual city. That's what a correlated subquery does, and it can get really slow, really fast. So, while subqueries are a fundamental tool, they can lead to some really messy, hard-to-read code. Queries inside of queries inside of queries. It's a nightmare. Thankfully, modern SQL gives us a much cleaner way to handle complex logic, common table expressions.
So what is a CTE? It lets you define a temporary result set, and here's the key part: give it a name. So instead of burying your logic deep inside a bunch of parentheses, you define it right at the top, give it a clear name like daily sales or active users, and then you just refer to that name later on. It makes everything so much cleaner and easier to follow. And you can just see the difference here. On the left, you've got that nested subquery mess. It's hard to follow what's happening. But on the right, with the CTE, the logic is flat. It's step by step. You build your first block, then your second, then you use them in the end. It's not just easier for you to read, it's a lifesaver for anyone else who has to look at your code later. But the power of CTEs doesn't just stop at making your code pretty. Oh no. This is where they go from being a nice organizational tool to an absolute superpower. I'm talking about recursive CTEs, which let us solve an entire class of problems that are just insanely difficult or sometimes even impossible with regular SQL. Anytime you have data that has some kind of hierarchy or a parent-child relationship, like an org chart, a system of file folders, product categories inside other categories, a recursive CTE is the perfect tool for the job. It's literally designed to walk through these tree-like structures. So to see how this works, let's use the classic example, an employee table. You've got an employee ID, their name, and a manager ID, which points right back to another employee in the very same table. Our goal here is to map out the entire company structure. Now, the word recursion can sound scary, but the logic is actually just 3 simple steps. First, you have an anchor query. This is your starting point. For us, it's the CEO, the one person with no manager. Second, you have the recursive part, which finds the next level down. So it finds the CEO's direct reports. And third, the database just repeats that second step over and over, finding the reports of the reports until it hits the bottom and there's no one left. And this is what it looks like in code. Don't let it scare you. It follows those exact 3 steps. That first select before the union all, that's our anchor. It just finds the CEO. The second select after the union all, that's the recursive part. And notice the magic trick? It joins the employees table back onto the CTE itself. That's how it finds the children of the people we just found. And step 3, the repeat, the database handles that automatically. It just keeps looping through that second part until the entire org chart is built. It's brilliant. Okay. So we've gone through subqueries, CTEs, even recursive CTEs. That's a lot. So the big question is, for your actual day-to-day work, which one should you use and when? Let's make a super simple cheat sheet for that. This slide right here, this is your key takeaway. For just connecting 2 tables together in a simple way, a standard join is your best bet. It's fast and clear. If you just need to check if something exists in another table, the exists subquery is highly optimized for that specific job. But the moment your logic gets complicated, or you need to reuse a piece of logic, a CTE is your new best friend. And of course, for any kind of hierarchy or graph, the recursive CTE is the undisputed champion. All right, let's wrap this up by talking about mastery. Part of being a real pro with this stuff isn't just knowing what to do, it's knowing what not to do. It's about knowing the common traps and how to step right around them. Here are the big pitfalls to watch out for. First, and I can't say this enough, avoid those slow correlated subqueries if a simple join can do the job. It's a huge performance killer. Second, with recursive CTEs, you have to have that anchor, that base case, to tell it when to stop. If you forget it, you've just created an infinite loop that will run forever, or until your database admin gets very angry. And finally, just use your judgment. If your query is turning into a mess of nested parentheses, that's a sign. It's time to stop and refactor it into a nice, clean CTE. I want to leave you with this final thought, because it perfectly sums up the mindset for each of these tools. A subquery is for solving a small, local problem. A CTE is for organizing the overall structure of a complex question. And a recursive CTE, well, that gives you the power to think in terms of networks and connections, to think like a graph. Master these concepts and you've unlocked a whole new level of what you can do with SQL.